Hello everyone and welcome back to another video. In this video we will ask ourselves the question, if I double the number of springs, will the motion become twice as fast? It sounds obvious, but it turns out to be wrong. Of course, we're going to test this with an experiment. We'll measure how fast a mass oscillates on 1, 2, 3, and 4 springs, and discover that velocity doesn't grow linearly, but with the square root. By adding identical springs in parallel, we increase the stiffness and measure the time for one oscillation. From these time measurements, we determine how velocity depends on the system and test whether it follows a square root relationship. So here we have 4 springs. First, we need to test out how each spring oscillates individually. Ideally, they should oscillate in exactly the same way. To test this, I have suspended identical weights onto each separate spring, and I will let them oscillate. As you can see, the second spring seems to be a little bit slower than the others. For our calculations, we're only going to use the first 2 oscillations, so the amount of error should be minimal. Here is a mass oscillating and suspended to one spring. As you can see, there are a bunch of extra hooks added. There are 5 hooks to be precise. This is because when I eventually suspend the mass to 4 springs in parallel, I will need 4 hooks, and since the hooks have a particular mass, I need to make sure that the total mass of all 5 hooks also is suspended with one spring. Alright, now to measure the time differential of one complete oscillation, we will check out the precise time when the spring is at its maximum stretch. So first the spring expands to its maximum stretch, then it compresses again, and then it expands again to its maximum stretch, and that will be one complete oscillation. Okay, so now the spring is at its first maximum stretch, and you can see the timing below. Now the spring is at its next maximum stretch. So this is one complete oscillation. Let's do one more oscillation. Okay, we have our data for one spring. Let's now do 2 springs in parallel. And now we have our data for 2 springs. Let's now do 3 springs in parallel. And finally, let's do 4 springs in parallel. Now we can calculate all the periods by taking the time differentials. And then we can calculate the relative velocities using these formulas. And to end this video, here is an overview table with all the data and calculations. So by measuring the oscillation times, we calculated the relative velocities. The results clearly show that the velocity does not increase linearly with the number of springs, but follows a square root relationship. Small deviations appear for higher numbers of springs, likely due to experimental imperfections, but the overall trend is very clear. Thanks for watching and see you in the next video.